running this code at home in the privacy of your own home will let you understand a little bit of how chunky it really is when I'm loading these avatars with a thread. So what we're going to do is fix that problem by using something called an async task instead. So like we saw, we're at least loading 5 avatars at any one time when the user scrolls, and although we can alleviate some of that, some of the slowness there with a caching strategy that makes sense for our device, um, there's still going to be some times when you'll just run into avatars that you don't have in the cache, or um, when the application starts up for the first time, you won't have anything in the cache, and we need to make sure that those situations work correctly too. So we need something that can manage all the work that's being done, because basically spawning off as fast as you scroll there, we could be spawning off, upwards of 20 threads or something, and that's just going to make the application run slow, as if we were trying to load all those things on the UI thread. So what we're going to do instead is use this class called an async task. Now the way I like to set it up is that the async task is a class that we'll create, and it extends async task, and I'll show you a little bit about that in a second. But I also like to put an interface on there that the caller class can implement. Like in this case, the list item view can implement that whatever interface the async task has, and the async task has all the information it needs to kind of tell the whatever client that's going to be working with it the way that it should work with it. That way it's really nice and reusable. And now I've got these almost completely reusable async tasks sitting around that any parts of the view or activities or whatever can reuse them. And I've actually seen benefit from this in the past. And they kind of almost work like the command pattern. If you've ever seen pattern discussions, it's kind of like a command, like just fire this thing off in the background and tell me when you're done. And that really helps to clean up your code. So let me talk a little bit about async task. So what an async task does is maintain a thread pool, which is a strategy to cut down on the amount of threads that are running at any one time, but to be able to work with and reuse the threads, and also to queue up any requests that are coming in to be done with a thread in a way that only so many are, like a manageable amount, are running at any one time. It also knows how to deal with progress. So if you have some asynchronous task, by the way, async stands for asynchronous. It means just like we showed in the last week's slides, some way of taking the work off into a side chain of work, sort of. But if you know exactly how much work there is to be done totally, you can also have a callback that posts the progress of your async task back to an activity. Now with network tasks, you don't know how long it's going to take, so you can't do that. But if you're doing something like processing images locally, you'd know like you've got 20 to process. Well, 1 are done, 5's done, 10's done, 20's done, we're 100% done. Now we're done. So you can post back that progress and have like a progress indicator or something like that. The async task also deals with callbacks. You can see down at the bottom, the yellow triangles, there's on canceled, on post execute, on pre-execute, on progress update, publish progress. Each one of those things, each one of those methods are methods that you can deal with that get called back when something is done. So basically, this whole class is about saying here's a unit of work to be done, and then it gets kicked off and it posts some information when certain parts of that work are done, and it's easy to cancel it, and it's got a lot more utility than a thread, which is just fire and forget, and packs up a whole bunch of work, which will make your application run just as slow as if you weren't even using threads almost. So like I was mentioning, I like to construct my tasks or build the tasks, architect the tasks, I guess, with an interface inside of it, like you see here. So this is the task that's going to be loading the avatars, but you could use to load any images that you wanted. as you can see at the top, it's got a generic setup, and it's going to take a URL. It's going to take a void for progress, since we're not going to post back any progress, and it will return a drawable. That's what those three things at the top mean. Those three generics at the top in the async task definition. And then I like to do an interface down there circled in green, which is what I expect anything that calls this async task to conform to. So that the interface will define a callback that I'll call when the image starts to load, if the image load is canceled, and once the image is completed loading, the callback that I'll call with the finished drawable that I've gotten off the network. And then each async task will hold a reference to whatever responder constructed it, and then the easy way to set yourself up as a responder is just to pass yourself into the constructor. So this isn't. I want to make clear this is not like the Android prescribed way of doing it. This is just something that I like to do, which I find really cleans up the code. So if you get benefit from this, then you can enjoy the benefits yourself, and let me know how it works in the forum. And so that's enough talk, I think. Let's go look at the code and see how this is actually implemented. So I'm going to close this down, close down step 1, and go look at step 2, week 3, and pull up Com O'Reilly Android O-Tweet layouts, status list item, and this is it's a really big text, but let me go through this code first, and then I'll put it side by side with the code from the previous step, and we can see the changes. So the first thing you'll notice is now, instead of now where there was no interface implemented at all, this list item is implementing a load image async task responder, which we just looked at in the slides. So this is setting itself up to get responses from an async task. It also now on line 24 has a reference to the latest load task, which is going to be a reference to the async task that we set up every time status is set. We're going to go load a new avatar, but as fast as the user scrolls, they may be loading through and making one of these status list items recycle faster than the previous avatar was able to load. So we want to be able to cancel the previous load every time a new one is set, a new status is set. So again, ignore line 32, but down here in set status, instead of setting up that whole thread business that I did before, I'm checking to see if the latest load task is not null. If it's not null, I know I need to cancel it. And then the signature there is it takes a Boolean, cancel takes a Boolean that says if we may interrupt the task while it's running. So there's different stages to the task. If it hasn't yet been running, then you can still cancel it, and then it just won't run when it comes time to run it. Or if it's in the middle of running whatever it's running, this true says that we can interrupt it. So again, once we set status on the status list item, if the latest load task is if there's a reference there, we want to cancel that previous load because it's just loading the wrong avatar at this point. It's too far behind. So we just want to cancel it and then start loading the new one. Down here on line 39, which we want to do in either case, we're going to set the latest load task to the response here from constructing the load image task, passing in this, and then calling execute with we're going to pass in the URL of the avatar, but I'll show you why we're passing in the URL and how that works in just a second here. But basically this is saying execute this task by loading this URL. And then you can see in this, let me zoom in here on line 42, a thing that Eclipse does to let you know that a method is implementing part of an interface is show this little hollow up pointing triangle. So this lets us know that we are implementing a method here. So image loading is a method that we're implementing that is defined by the interface. Let me spin open the code here, and on line 7, it's defined by this interface, the comma O'Reilly Android O-tweet tasks, load image async task, load image async task responder, which is what we implement. And I mean, all that's like, just putting a fine point on it, but it should be fairly clear from the image name what's happening. So since we implement that interface, once we kick off the load image async task, we will get called back by that task when the image starts to load. And now, in this case, when the image starts to load, I want to clear out the old image drawable, so while a new image is loading, I'm not seeing the wrong avatar. I could also start to show progress here if I wanted to put a little progress spinner in the avatar, although I find that for this design to be a little too distracting. So right now we're just setting that to null while a new avatar is loading. And then if the image load is canceled, in this case, we're not really going to do anything, but still the interface defines that we need to have something. We could instead, like in a different case, if this load image async task was being used to say load like the picture from TwitPic or something like that, if we could have the user able to cancel it, and then we could switch the icon or the image view that we were displaying that picture in to show like a broken image or something like that, to show that we didn't finish loading the image. That's just an idea, but that method is a callback that is defined by the interface. And then on line 50 to 52 is the callback that will get called when the image load is done. And then in that case, all we need to do is set the drawable on the avatar view. So I think this, although we've increased the number of lines in the code, I think we've increased the readability a lot, because these methods make a lot of sense, that you just read them and you know what's happening. So while the image is loading, we're going to do this. If the image is canceled, we can make some choices there. And once the image is loaded, then we get this drawable and we just do what we need to do, which is set the avatar to that drawable. So that's one benefit to using an async task right there, right off the bat, without even looking at it, is it cleans up the code a lot, instead of having threads hanging around all over the place with runnables hanging around that are calling over to these methods, which finally do the work that we need to do. It's just a lot cleaner. Okay, so now let's look at load image async task and see what's actually going on. Well, actually, before we do that, let me compare, because I was kind of talking about that just now anyway. Let's just compare what we had before with the threads and the handlers. So I'm going to put the old code on the left, the new code on the right, and let's kind of just go through here. One difference is now we're implementing an interface, whereas we weren't before. We've got to have this drawable hanging around to do the actual, a runnable hanging around to do the actual work, which is a little confusing. And we put the best face on it we can by trying to name this runnable something that makes sense, but still it's confusing. What is this guy going to be doing? Then we've got to go through this whole mechanics of loading up the thread. And you could probably make this better in the code some other way, but still you've got to define that thread somewhere, and that's got to define this inner method run, which actually does the work. And then all of a sudden your code here, although you could again define this thread somewhere else, but if you didn't, then your code, now the status list item has to know how to load avatars from the network. That's not a good breakdown of responsibility. It should just be tasked with displaying avatars that it gets. So in the new code, the load image async task knows all about how to load avatars from the network or from our cache or whatever needs to be done, and the status list item doesn't need to know about that. So that's a win from an architecture standpoint. And then we've got to have this method that's called, because we have to do this little dance where we can't actually modify the view hierarchy from the thread. So we've got to have this other method hanging around that's just a method to be called by something that can't modify the view hierarchy. So there's a lot of things that we're able to clean up by using this load image async task, and I hope that all seems as good to you as it does to me, because I think it's a much better, cleaner architecture here for this view. All right, so let's go in and look at the async task itself. All right, so like I talked about in the slides, when I wasn't really able to point at anything, let's go through this one more time. The signature for async task is, let me hover over the help here and see if it well, okay, so it replaces the generics, but it's got the definition here, or the documentation here. So I can zoom on this a little bit. Um, so what it says is async task enables proper and easy use of the UI thread. So it's set up to perform background operations without having to deal with threads and handlers, so it's a lot better. An async task is defined by 3 generic types called params, progress, and result. So if you understand generics, those aren't classes; those are just placeholders for things that you define during the when you extend it, like right here. So what we're saying is this first. The params generic is an URL, so that means when you call execute on the async task, we want to be passed in a URL, a java.net URL, something like I don't remember the package structure there or the fully qualified name, but we're going to pass in a URL once we want the task to execute. Then progress is the second generic, and that will be what type of data, what type of class or whatever is returned by the progress update when you do something, as you can see right here in the documentation, called publish progress. So if we were to know how long it would take to load the avatar from the network asynchronously, we could be publishing progress as we went through and saying like there's 20% left, 5% left, okay, now we're done. But we don't know, so we're not actually going to be publishing any progress, so we can just put in this void class here for the second generic progress. And then for the final generic result, that is the type of class that's going to be returned to when the async task is done. And in that case, for us, it's a drawable, so that's going to be the result of our execution. So now let's look at the methods that we implement, and then we'll come back and look at this interface. I've just twirled this down a little bit here. And I'll twirl this down, so we'll look at this code in a little bit. But for right now, let's look at how the mechanics of an async task. So the first thing to do is you have to override do in background. And do in background, the method signature is that it takes a variable argument, which is new, and I think Java 1.6. The format for a variable argument, if you haven't seen that before, is some class and then a ... or some argument type, some type and a ... and then that's going to be and then whatever the name for that you want to be locally, and that will be an array of those types. So we're expecting URL to be passed in, but what's weird is since it's var args, variable arguments, we're actually going to have to pull that out of an array of URLs. So since we're only expecting one, we're just going to pull that out of position 0. So arg0 will be the URL that we want to load in the background. And we just do this same code on line 27 like we used to do in the threaded version. Just drawable create from stream, and then it needs some sort of key, so we're just going to use toString on that. It doesn't really matter what that is, luckily. Now, so if you're in a situation where you need to pass in arguments of more than one type, you could just change this to object or something like that, and then just pull things out. So it's a little weird for Java people to see this kind of interaction in the code, where you're not really specifying what types. You're kind of being a little bit, or how many things are coming through. You're being a little bit more dynamic almost here. But in any case, do in background is what does the work. It's what takes that first a variable argument of the first generic type that we set up in async task right here on line 10, and then it returns the result generic type, which we set up on line 10 here in the final generic type of the 3. So do in background needs to take the arguments we're expecting and return the arguments that we're expecting returned from the result, and basically do all the work. And so that's where the meat of the task, the async task, is. We never call do in background. It's an internal class. It's what the async task calls when it's ready to do its work. And then as part of the rest of the mechanics, on pre-execute is a callback method sort of that you can override if you choose to do some work before the async task starts its actual execution. So what we're going to do is call back to our responder and say that the image is going to start loading on pre-execute. And then on canceled is a callback that will get called if the async task is canceled, and we will just call our responder and say that the image was canceled. And on post-execute is the method that you will that will get called, the callback that gets called with the result, with the class of the result that should be returned from do in background, the worker method here on line 24. Whatever that returns, in this case a drawable, is going to be what is passed into on post execute. And then in that case we're going to pass that result on to our responder in image loaded. So our responder, this is what I sort of glossed over a little bit, is of type load image async task responder, and we keep a reference to that on a private variable in line 18, and that type is defined on line 12 here. It's just an interface that defines those three methods. So again, this is what I mean by kind of packaging up the interface with the task so that the task is sort of atomic, and it says this is what you need to respond to, this is what I'm expecting to call when the different points of my execution are happening. If anybody wants to be my responder and tell me to go load an image in the background, they need to implement this image loading, image canceled, and image loaded methods. Okay, hopefully that makes sense to everybody. And you can see how it's actually working here on the status list item. All we do is say create a new one of these async tasks, pass in ourselves, and since it's expecting to be load image async responder or async task responder that's constructing it, this should all work fine. And then we call execute, and then the work should start sometime in the future, fairly soon, hopefully. And then again, these three methods will get their callbacks at the appropriate time. So let's look at this actually running. I need to go to the project, step 2, run as Android application. And let's look at this. I'm not sure if this is actually going to show up over the network, but it's going to be a lot smoother. The scrolling is going to be a lot cleaner once these tweets are loaded. And then I go through. The avatars are going to be loaded at about the same speed, but as I scroll through here, it's so much cleaner. It's actually, it seems like I'm actually scrolling through the list instead of like telling it to scroll, and then it says, oh, sure. Oh yeah, I'll scroll in a couple seconds, and then it does. So much more, it's much better user experience to see the application working the way we want while we're doing some work in the background, and then finally when things catch up, the avatars are actually loaded. And again, that would be a lot quicker if we had a smart caching strategy as well. But I think you'll agree that we've made a lot better architecture for the code. So, in summary, async tasks are much better suited to running a lot of things in the background than trying to spawn off your own thread yourself. So, that was a lot. That was a big chunk of content. Any questions for that?
Yes, we actually have a bunch. So I will start with one. There was a question about how the async tasks and the reuse of the status list items work together, because if we are reusing those items as you're scrolling, do they each get a new task, or how does that work?
Every time I call set status, which is when a new tweet is loaded, that means like somewhere in the chain it got reused. The status list item got reused. I'm creating a new async task every time. And if the old one is still there, I cancel it, and once I set this new reference here on line 39, that old one will get garbage collected at some point. So every time I set status, the status list item creates a new async task. Does that make sense?
Okay. Yep, it makes sense to me. Hopefully the person who asked the question, it makes sense to them. Ernest in our audience has a question.
Hi. I was curious if you can control how many threads async task will create, or if it just automatically handles itself.
No. So the first time I discovered async task was I've got a little bit of a story here to tell. Sorry. Um, yeah, I think even before Java 1.5, I mean Android 1.5, I saw some sample code that was actually created by Google engineers. I think the code is up on the forums. I have it it was in a Google Code repository, and it was called Apps for Android. And I was poking around in there trying to figure out how to do something. I can't remember what. And I saw them using this class called user task. And I looked at that and I'm like, well, this is great. I don't have to do this threading stuff anymore. And it was actually kind of a precursor to async task. And it wasn't actually in the Android framework. So all I did was just copy that code from that class and put it in my project, and I used it. But what I was doing was actually, this is when I was working on an application called Brightkite, which is actually pretty similar to Twitter. As far as displaying these things, there was a lot of different posts that we were displaying, and next to the post we were displaying the avatar of the user who had posted the post. It turned out that the size of the list was such that we were loading, every time the user scrolled fairly quickly, we were loading over 20 avatars at any one time, and the user task thread pool was set to 20. So it was only allowing 20 to be created, I think. And so it failed with some error, like too many. You queued up too much work for me to do, basically. So all I did was go into that code and say to increase the thread pool size. Now, fast forward to Android, I think 1.5 and beyond, async task is part of the framework. So that code is inside the framework, and sadly, you can't change the size of that thread pool. So the answer to your question is there's a limit to how many it'll run at any one time, and it doesn't really work. It doesn't work with I'm not really sure about how all this stuff works in Java, but there's some way to say create what's called a future task and queue that up for execution later so that it'll turn into a thread and be pulled out of the thread pool and worked on at the right time. So basically, if you do too much work with an async task, and luckily we're not running into that problem here, you will get an exception, and there's no way to change that thread pool size. So does that answer your question?
Yes, thanks.
What you could do is, because the code is pretty much the same, you could go hunt down that user task guy on Google Code and use that instead, and just change the thread pool size. I don't know. That's one way you could do it. Well, actually, I put in an issue on the Android Android code site where they keep all of their bugs and issue tracking. I put in an issue to be able to change the thread pool size for async task, and they denied it. They said they won't fix it because they want it to be just the way it is. They don't want it to you to be able to change it, and such that you can completely, wreck your application by doing a lot of work in the background.
From the chat room, is it necessary to initiate an async task every time we need to update the status?
Yes, it is, because once it's done or once you cancel it, there's a workflow there. There's probably something like a state machine, and it can't be reused. So it's just it would probably be as much work to reinitialize the thing as to just create a new one. So, but in any case, you can't reuse it once it's done. You need to create a new one.
Hi, Tony. This is Ruth. So I have a bunch of questions queued up here, and I'm trying to kind of group them. So are you relying on a list item recycling to limit the number of async tasks running concurrently?
I guess I wouldn't say I'm relying on it, but it is limiting the number. I mean, I guess not really, because the user can scroll super fast. I mean, if they went to load older tweets a couple times, say 20 times, since we haven't limited the amount of tweets that are being shown, they could be scrolling really quickly through hundreds and hundreds of tweets, and we could, if the network slowed down at any one time too much, it may end up to be too much work being done or being queued.
Okay. And then someone asked, isn't it risky to wait for a call to image loading to set image drawable to null?
there may be a gap of time there. So, okay, let me clarify what he's asking. This image loading is where I'm clearing out the old avatar, and that will be called by the async task once it starts to execute. So there could conceivably be some gap of time between line 39 and line 43 where the user will see the old avatar. I don't know if you're really worried about it, just go do this. But I kind of wanted to have some reason to have image loading or something like image loading called so that you could see that there's this pre-execution phase. And it turns out that there's not really that much, like the tasks get kicked off quick enough so that there's no gap where the user will see the old image. But if you're worried about it, or if you actually run into the case where it is a problem, just do whatever initialization you want in the actual place where you kick off the task.
Okay, and then I have on image load canceled, you don't need to do anything, and you don't need to specify to stop loading the current avatar. So if you cancel this, it seems like the person is concerned that it might just keep loading.
Well, no, it would only be called if the task was canceled, which would stop the avatar from being loaded. So that would only be called if it was already canceled.
So you might want to do something in another scenario where you would actually show that, like you were saying, showing a broken image or something, and this is where you would set that up.
Yeah, yep. And in this use case, I mean, admittedly, I made this code so that you could see that there were different phases to the async tasks execution. In this case, I don't really need anything like that, like the image canceled. But you'll also notice that load image async task isn't called load avatar async task. It's general enough to be able to load any image you want off the network. You just need to pass it an URL. So we could use this, like I mentioned, for loading a picture from TwitPic or something like that. And then in that case, you may, since it would be a bigger picture, you may want to allow the user to cancel, and then you may want to do something in that case.
A lot of questions, and it all seems to revolve around the theme. Last week we talked about spawning our own threads. Today we're using async tasks. So people are kind of curious about when do you use one, when do you use the other.
I never use threads. I always use async tasks just because of what I talked about in the architecture. It's so much cleaner and more palatable in the code to me to see an async task having some clear responsibility and the view or the activity having its clear responsibility, and there's no overlap between them. So I don't create the thread in the activity, and that thread all of a sudden has a bunch of responsibility that the activity shouldn't have, like knowing how to do some work in the background, like loading an image. I never use threads. But a more general answer might be if you have some work that can be done in the background that is of its own like type, and you don't expect a lot of that work to be done in the background. Like, okay, when we load all of the tweets up front, that's like a one-off. Go load the tweets, come back, tell us when it's done. As opposed to the avatars, it's like load 20 avatars at a time, and then when each one of those are done, they will be some action will happen on the UI. In the first case, it's fine to use a thread. In the avatar case, you need to use async task or do something. If you want to write your own code, you can maintain a thread pool yourself somewhere and then queue things up that way. You just can't have that many threads spawned off without some sort of control in the background. So it's okay to use threads when there's not going to be a lot of other threads running at the same time. Or you could just always use async task like I do.
Yeah, it makes it a lot easier to understand. I think the code does look a lot cleaner.
And a corollary question to that is, isn't there something like async tasks for us in Java, pure, as opposed to just Android? That'd be really awesome.
Well, I mean, you can go see the code. It's open source, and I still don't understand a lot about concurrent programming in Java. I'm like, I know how to make it work. I know why, and I know sort of how, and I know where to go to get the code, I guess. But going through that code in depth will help you understand concurrent programming pretty well too. So I would recommend looking that up. And I think the link to the source code is on. In general, the Avatar source code is on our forums. So check it out.
Thanks a lot, Tony.
Yep.
I have a question from GoToWebinar from Mary. Can you use messages as a handler within the async task to implement a state machine? Is there a message queue associated with the async task?
I don't know if you can get access to the inner workings of the async task. You'd have to do some sort of application-wide state machine stuff. I mean, each one of the transitioning between the states, you could probably do that with an async task if something needed to be done in the background. But they're like they have a definite lifespan. These tasks, once you cancel them, you can't reuse them. Once they're finished, you can't reuse them. So they're like you don't keep them around once they're done.